Okay. So did you get official mail of rescheduling the class?
Yes.
Okay, because I mailed them also. So okay, let us wait for a few minutes, then we can start.
Okay.
Hmm.
Debye-Hückel limiting law is related to this topic, this chemical potential or
Yes. So I actually did not gone through the lectures uploaded in this video in this week basically. So did she taught the biological limiting law?
in the last lecture there was the formula in the sheet
Okay, okay, then we can discuss.
and the colligative property also discussed in this week.
Colligative property is basically known to us actually from 11, 12, you know. Even in so that's why colligative property, that binary mixture, these things, right? That's why I did not gone through this lecture.
Yes, but the relation with chemical potential to this colligative
Mhm.
property.
Okay, so I'll go through because I have to. I will returning in campus tomorrow. After that, I can go through the lectures. If there is any extra information or extra thing we should discuss, then I will discuss in that in the next week. Okay. And
Okay,
also, we will discuss the Clausius-Clapeyron equation and the question related to the chemical potential, activity coefficient, even Debye-Hückel formula, these things.
okay.
Okay. So already 2 minutes gone. So now we can join. First times. Yeah. Today my health is not very good. So okay, is it visible?
Yes,
Oh, I think it is visible right now. Okay. Start. First, let me connect the earbuds. So let us start with the Clausius-Clapeyron part. Just I'm writing the question. Discuss about the Clausius-Clapeyron equation. Okay. So what is the Clausius equation? First, that is dp dt. Sorry, or it's okay. dp equals to delta H by E delta V into dt. Okay, so this is our Clausius equation. This can be written like this as well. dp dt delta H by T delta V. Now, this is related to the phase diagram. That phase diagram we had discussed in the last week. If you remember, that was a PT curve, right? Because that was
Yes.
connected to P and T. So this dp dt basically the slope of the curve. This is signifying. And what does it mean? The slope will be uh, related to the delta H of that process change and delta V of that process. That's it. At a particular temperature, if you consider. So, if you remember any plot, let's say I'm just drawing a phase diagram. So here it was P and here it was T. So let's say for water, if you remember, it was like grossly like this. So here for any plot, any curve, if you consider, let's say this, if you consider this curve, this is solid, liquid, gas. This curve, if you consider this liquid gas curve, then the dp dt means the slope of the curve. How that can be calculated? That can be calculated. Okay, this formula is always valid. If you remember this is valid for phase transition. Okay, why? Because you know this dp dt is a curve, right? A slope of a curve. So there must be a curve, and any curve in the pt plane will signify a phase transition. Is it clear?
Okay.
That's why this dp dt is actually the uh, change in pressure with respect to temperature on a phase transition. So here this liquid gas curve, this is liquid gas phase transition curve. If you consider the in this curve, this dp dt will be delta H of that transition phase transition divided by T by delta V. This is the Clausius equation.
For phase transition, dp and dt both are 0.
dp and dt both are zero means no.
For ice to water,
Hmm.
it
That
is a
how?
isobaric and
That
iso.
I'm just saying, just let's say if you consider this curve, right? This liquid gas curve means water to vapor, right?
Yes.
So this water to vapor is a phase transition process. So this phase transition process basically occurs at 1 atm and to 373 Kelvin. Okay. Now if you change the temperature, then you have to change the pressure as well. Okay. So let's say if this is a 373 Kelvin, then this is the pressure 1 atm. So now if you change the temperature, then automatically the pressure will be changed because the degree of freedom was 2. Sorry, 1. If you remember, degree of freedom was 1.
Yes.
You can change only 1. So that's why this dpdt means you can change pressure or temperature, then automatically other quantity will be changed. So this is the dependency of pressure or temperature with respect to each other. Okay. So how, if you change the temperature dt, or if you think like that, if you change the pressure P to dP, P plus dP, then the melting point or boiling point, the transition point will be changed to P plus dt. And this dP dt will be calculated, can be calculated using this formula. Okay. You get
Okay.
it? Okay. So this is the formula. This is the Clapeyron equation. And this is general. This is true for any phase transition. Okay.
For any substance.
Yes, for any substance, any phase transition, but that must be a phase transition. Because if it is not a phase transition, then what does it mean by dPdt? Because that then there is no curve.
Yes.
Slope will be exist only if there is a curve. Okay. So here delta H is essentially delta H transition, and delta V also the delta V transition. That may be any transition. Okay. So
Delta H
now,
is equal to latent heat.
yes, delta is equal to, because this heat, how you can calculate it? Let's say you know dH was, how it was calculated? Du
PdV.
plus VdP.
Yes.
Okay. So now, if you now from first law, what you know, du equals to d cross q minus
PdV.
PdV. So okay. So
Yes,
what?
dt minus VdP.
Okay, minus d cross q minus VdP. So this is the latent heat, and when you calculate it a constant pressure process, so basically DHP is the, if you integrate it, then it will be a latent heat.
Okay.
Okay, now so this is given to us. Now you can simplify this equation. First, let's say you consider a transition from solid to gas, or you can consider transition between liquid to gas, any two. That means this transition curve or this transition curve. If you consider, then what you can write, the delta V transition, let's say for solid to liquid, yes, solid to liquid, it will be VL minus VS, correct? Sorry, solid to gas, sorry. Okay,
Yes.
so you can write it as VG approximately. Is it clear?
Yes.
Okay. Similarly, here also delta V liquid to gas, that you can also write
V liquid gas.
V gas. So clearly for these two transition, you can directly rewrite the equation like this. Okay. And if you consider ideal gas, you know this will be nRT by
P.
P. So if you put it, then it will be delta H, it will be nRT by P. So you can write it delta H nRT square dt.
Yes.
So now you can integrate. So this I'm writing like this way. So it is P1 to P2. It is T1 to T2. So eventually it will be ln
Then P2 by P1.
P2 by P1 equals to del H by nr.
1 by T1 minus 1 by T2.
Yes, it will be minus 1 by T, clearly minus 1 by T. So now if it is minus 1 by T, then it will be 1 by T1 minus 1 by T2. Okay.
Okay.
So this is our Clausius-Clapeyron equation. Means in minus, no, right, it's correct. So in general, it is written like this, ln of transition. Okay, so this is our Clausius-Clapeyron equation. Previous one was the Clapeyron equation, and this is the Clausius-Clapeyron equation. Sorry, I think previous was Clausius. I don't forget what is the but this is Clausius-Clapeyron. Probably this is the
This equation is
Clapeyron.
Clausius-Clapeyron.
Yes, previous one I think the Clapeyron equation. This one, the general one. This one I think yes, this is the Clapeyron equation.
What is the difference between them?
This is general equation, Clapeyron equation, and this is for particular these two transition and considering the ideal gas. Yeah. Okay,
Okay.
this is approximated obviously.
Is it valid for gas to solid or not?
Yes, gas to solid obviously.
But solid to liquid not valid.
That I will come later. But when you are considering gas to solid, then it will be Vs minus Vg. You have to take care of that sign.
Minus Vg.
Minus Vg will be there because the when you are changing gas to solid, the volume will be decreased. So that you have
Yes.
to keep in mind. Sign will be different, but the treatment will be the same. This is the Clausius-Clapeyron equation. So you can remind this. It is better to remind, or you can directly derive from the general equation. It's not very difficult to derive 3 or 4 lines. So from here, you can rewrite this like P2 equals to P1 into to the power delta H by nr 1 by T2 minus 1 by T1. Okay. So you can see this is
Okay.
an exponential behavior.
Yes.
So that's why these curves are exponential. These two, solid to liquid and liquid to gas. Solid to gas and liquid to gas. These curves are
Yes.
exponential in
And
nature.
this one is not exponential.
Yes, that we can also see. But here it is clear. This is
Yes.
exponential. Okay. Now the next one, if you consider the another transition, that is our, this is very important. Solid to liquid means the melting. So here you can't consider that delta V equals to something. You have to write delta V equals to V liquid minus V solid. Here you don't know whether it is positive or negative. Here you know this is positive always. But here you don't know whether it will be positive or negative. So when
Liquid is greater than solid.
no, that is not true. For water, liquid is smaller than solid.
Yes.
So this is not general. So there will be two cases eventually. But in general, you can consider the delta V. Okay. So if it is delta V, then you can write it dp. So dp dt equals to delta H by T delta V. So this is totally general. Okay. So what you can do, so P2 minus P1
equal to del H by del V ln T2 by T1.
ln T2 by T1. Okay. So you can see this is if you write it like this, y is equal to mx plus c kind of. It's
Yes,
linear. Or you can feel it here y is eventually p, yes, p2, and x is t2. So t or p, whatever you want to write, but then you have to expand this ln part, then you can do it. This is not very difficult. But this is it will be not totally linear, but if you consider that t2 by t1 is very small, okay, then it will be directly linear. Clear?
yes.
Okay. Just you have to expand this, but this is not that much important, but it's clear. So it will be uh,
If I
this is the
expand the
formula.
ln part, then it will be exponent.
Let's say you can write p2 equals to p1 plus delta t or something, whatever you want to write, but this is depend on if p2 by t1 is very small. So ln x, what is the expansion of ln x? Ln 1 plus x is just x plus x square plus 2, like this, right?
Yes,
If you remember, let me all check once again. Expands ln series expansion. Yes, this is x plus 1. So ln x plus 1 is x minus x square by 2 plus just Taylor series, like this. Okay.
okay.
But now if you write it for ln x, better, if it is better, let's say I am writing it's like t1 plus delta t. We can write it. You can write it this as delta p as well, because we have already integrated it. Okay. So now if you
Okay.
expand it, that was I am saying, if this delta t is very small, this change, this is not very large, then you can ignore higher order terms.
Yes,
In that case, you can write it as delta
del
t
T
by
by T.
delta t by t. So clearly it is linear. Okay. Okay, but this is not necessary. We can consider this general formula as well. But what is important here, this slope, this is the slope, right? Slope of the curve.
Yes,
So this slope of the curve will totally be determined by the sine of del v, because other things are positive. This is positive quantity, this is positive quantity. If delta v is positive, then dpdt will be positive. If delta v is negative, dpdt will be negative. For liquid, for water, ice to water transition, what happens? This delta v is negative.
negative.
That's why this slope is negative. This slope. Okay. So this is important. Okay.
Okay.
Okay. So it's okay. Now, okay. So this is the Clausius-Clapeyron equation. This is not Clausius-Clapeyron equation. This one the Clausius-Clapeyron equation. Okay.
Yes.
Hmm. Now we can solve few questions. regarding this. Okay, let me drink some water. Okay. So question number 2. The specific volume of liquid water is ml per gram, and that of ice at 0 degree centigrade. If the heat of fusion of ice at this temperature is 333.88 joule per gram, the rate of change of melting point of ice with pressure of VATM inverse, then will be okay. Just read it and try to do it. Just you have to apply the Clausius-Clapeyron equation or Clapeyron equation, whatever.
What is the pressure?
What is the pressure means?
Value of the pressure?
This one.
Yes, I am
I
applying the
don't know.
formula P equal to del H by del V into delta T by T.
What? Yes. Now try, it's easy. Just this is the unit of slope.
Okay,
This may be degree is written. That means degree Celsius, degree Kelvin, or degree Fahrenheit, anything. The change will be the same now. Try, otherwise I will do. just see from here, they ask to calculate the rate of change of melting point of ice with pressure. This is the unit. This means they want to ask dp.
Yes.
But from Clausius-Clapeyron or Clapeyron equation, you know this. So just you have to reverse it
Yes.
because these are exact differential. So you can write it like this. Okay. So first you have to calculate this one dp dt. So what will be dp dt? It is just
Del
delta
H by
H by T,
V delta V.
T delta V, and this is solid liquid transition. So it will be just V liquid minus V solid. Correct.
Yes.
So if it is, so dt dp will be just reverse one, this one. Now just look at the data that is given. Specific volume of liquid is given. Ice is also given. So these two data are there. So just put it first. For liquid, it was 0.001. Oh, sorry, 1.001 minus for solid it is 1.0907 and unit is ml per gram. Okay, next this is 0 degree, so it is 273 Kelvin, and the denominator will be delta H. This is given also. This is 333.88 joule per gram. Okay, so gram per gram, this will be cancelling out. Now it will be 273 into what will be this change. Just do this calculation. Let me also do 1.001 minus 1.0907. So it is minus. Obviously, because already you have discussed for liquid, for water, liquid to solid to liquid transition. In case of solid to liquid transition, the volume will be increased. Sorry,
Yes.
decreased. For liquid
Minus.
water, yes. So it will be negative. It will be 0.0897. The unit will be ml, milliliter. So it is into 10 to the power 3, then it will be liter divided by 333.88 joule. Now you have to calculate this liter and joule. So 1 liter is 1
101.2 joule.
1 decimeter cube.
Yes.
Okay, and 1 decimeter is 10 to the power minus 1 meter. So 10 to the power minus 3 meter cube. Okay,
Okay.
so here it was milliliter. So from milliliter we have converted to liter and now meter cube. So again 10 to the power minus 3 will be there. So then it will be a meter cube. And joule, what is the unit of joule?
What?
Joule. If you break the joule in the basic unit, then what will it be?
Newton into meter.
Newton into meter. Correct. So it will be this. Now Newton, because you have to go in the basic unit, what the ATM they have asked. So you have to convert the ATM. This unit, because they are ultimately there will be the unit of pressure. So just you have to get that. How you can get that? In
Newton per meter square is pressure.
Newton per meter square is pressure, but that is Pascal,
Yes.
not ATM. So you need the ATM. So how you can do? Either you have to remind the relation between Newton per meter square means Pascal and our ATM atmosphere. Okay. Otherwise, what you can do from the unit from the value of R, you can calculate.
Yes.
What is the value of R? 8.314
For Joule,
joule per mole inverse
Kelvin inverse,
per Kelvin inverse. And in liter ATM, it will be
1.987.
987
Sorry, it is in calorie. This is 0.082.
0.084 82, I think. Right?
82.
हाँ, liter ATM mole inverse Kelvin inverse. Okay.
Okay.
So if you equate, then it is clear from this two lesson. Just remind whether it is correct or not.
Yes, it is correct.
So you can write it liter ATM. So previously, what was the unit? So just erase this.
Joule.
So with liter, Kelvin, and joule. Okay. So just it in for 1 joule, it will be 0.082 divided by 8.314 liter ATM.
Yes.
So that upper part will be, so just it is very easy to remind this, then you can easily convert.
This is a very new trick.
Oh, you did not know this?
No.
Okay, because always there's Newton, Pascal, bar, ATM, this is very complicated.
Yes.
It's better to remind this, and also the other one, that 1.197 or 987, this one, calorie, calorie mole inverse Kelvin inverse. This is easy because you know this relation 4.2.
Yes.
Okay, so dTdP will be now minus 273 into 0.087 897, sorry, 10 to the power minus 3 divided by 333.88 into this 0.082 8.314, and it will be liter Kelvin by liter ATM, and this will be cancelled out, only Kelvin and ATM will be there. So this is the unit they asked.
Yes.
So just calculate it and check what is the answer. Let me also calculate, just calculate.
7.436 into 10 to the power minus 3.
Okay, just let me check. Hmm. So it will be, so this will be the change. So just see this problem was easy, but where the people will start stuck in this conversion. If you don't know, then you can't proceed.
Yes.
Okay. So now the next question. This is also related to this electronic equation. The vapor pressure of, of decane is 10 torr at 55.7 degrees centigrade and 400 torr at this. The delta S of vaporization at 100 degrees centigrade will be. Good question. It's not very straightforward. Right? Okay, how you can approach?
What is the relation between this and the vapor pressure?
Pressure, that's just pressure.
It is only
What is,
pressure.
no, no. If you remember the formula of lossless Clapeyron, what is this? These are vapor pressure because already you have considered the gas.
Oh yes.
Okay, because there is no pressure of liquid. Just let me check everything is going on. Okay, it's going on. তো তাই যদি করিস তাহলে পৃথ্বীর সাথে কথা বলে নিস কখন বেরোবি না বেরোবি। হোয়াট ইজ দ্য অ্যান্সার?
I am calculating it.
ওকে ওকে ওকে। Okay, so let me try. What will be delta H?
What?
Delta H. This one.
Yes.
Okay. And we are talking about, this is very tricky question. This, right? Liquid to gas.
Yes.
And for liquid to gas, what will be the delta G? this liquid to gas phase transition, because this is a phase transition. At phase transition, this is 0.
Yes,
Now it is straightforward. Then what you can write? Delta G liquid to gas equals to,
minus T delta S liquid to gas.
and you have asked to calculate this one. So simply this will be this. Okay. And how this you can calculate from Clausius-Clapeyron equation. From yes, Clapeyron equation or Clausius-Clapeyron equation. So what will be that? Because it is liquid to gas, so you can directly use the Clausius-Clapeyron equation. This was
ln P2 by P1 equal to del H by NR 1 by T1 minus 1 by T2. Yes, minus sign.
this one. So we need to calculate this, and every data is given to us. Just put it. So ln P2 is 400 torr, P1 is 10 torr, and it is delta H liquid to gas. Okay. What is the N? Anything is not given, so N is 1. This you know, because if there is no given, so this data you have to consider molar data.
Yes,
So it is 1 and R is 8.314. T2 and T1. T2 is okay. Okay. So this is, you can write T1 minus T2 or T2 minus T1 divided by T1 T2. And T2 minus T1 will be, if you calculate from here, this is our T2, this is T1. So T2 minus T1 will be 150.6 minus 55.7, and T1 into T2. Here you have to add 273, so it will be 253.6 into 328.7. Okay, so eventually it will be, this will be 94.9, and here it will be ln 40. So this, so now calculate it. What is the answer? Let me calculate as well. This is 44998 joule. Okay, is it matching?
I am doing this.
Okay, okay, just do it.
Yes, 0.0741.
What is 0.07? Okay, that you can ignore. So delta S will be,
This divided by T.
what is the T they have asked? Of which T? 373, right?
373 Kelvin. 120.638.
So this is the answer. So, so see here, calculation part is trivial, but just you have to know these. Otherwise, you can't do it.
Yes, I forgot it.
Hmm. Then it is trivial. But if you don't know it, then you can't do it anyway. Okay. One more question I have related to this. Okay. So question number four, I think. Oh, six. It is six. Four. Yeah. Why I have written five? Okay. Calculate change in temperature boiling water when the pressure is increased by this. The normal boiling point of water at 1 atm is, you know, another two data are given. Okay.
Okay.
So directly from the equation based question. Just do it, then I will check. Okay, let me also proceed. So we know this is the Clapeyron equation, right?
Yes.
Okay. So they ask the change in temperature of boiling water when the pressure is increased. So the reverse one again. Mm, Normal boiling point, you know. Okay. So here also liquid to gas because boiling is considered. So from here you can write dt equals to V gas minus V liquid divided by del H into T dp. Sorry. Okay.
Yes, I'm getting the same.
Hmm. Now what is known? Hmm.
Everything is known.
No, but it's dt and dp. Correct.
DP
So
is
so uh, latent heat means delta H.
yes,
Specific volume of steam is given. Okay. Okay, you can change it. How? Okay.
yes,
This you can change like this.
yes,
And Vg is nRT by P.
yes.
So this is the formula, the Clausius-Clapeyron equation we have obtained again. I think, if I'm not wrong, am I correct?
We have to done dt by t square after removing the t inside.
Yes, 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 yes. Because here also a t, right? So it will be, it's t, but when you put it, so it will be nRT by like this.
Yes, 1 by t1 minus 1 by t2. Okay.
This is correct. Okay. Now we have to calculate the delta t. So delta t, it is obviously t2 minus t1. So delta t, then it will be t1 t2. Then it will be, but you see here t is, so what t you have to consider? No, no, no t will be there. Sorry. So delta h ln p2 by p1. So this formula. Now you have to just put the values, everything you know instead of t2, because you don't know t2. You have to calculate the t2. Correct?
Yes,
You know, you know only the uh, p1. What is the p1?
373 Kelvin.
373 Kelvin, and associated p1 you know that is 180 m.
Yes,
And you know p2, which is p1 plus delta p. Correct? So that is this,
yes.
but this is in uh, millimeter of Hg. So 1 ATM is, you know, this is
760 millimeter is
6, yes, 760 or 76 centimeter. Okay. This, so it will be now 760 plus 27. So it will be this P2. So P2 and P1 is given. So you can write it as NR. N is 1, let's say. N is 1. So R is given. R, this will not have any unit. So only R will give the unit. This will be unitless anyway. and delta is given is calorie in calorie. If you see, it is in calorie, so it's better to use the unit in calorie. So what is the value in calorie of R?
1.987.
Okay, mole will not be there because it is for 1 mole already. Delta H is
537.
calorie per gram, and it is ln P2 by P1, which is 787.12 by 760. We can do it or not.
Yes.
Now, if you do it, now calculate it. The right hand side, it will be
1.297 into 10 to the power minus 4.
1 minute. Here is something fishy because we don't have used the volume.
Yes.
That data is also given to us.
But we converted the volume into pressure.
That's correct. That's correct. You are saying which volume it is. Volume of specific volume of steam. What does it mean? Specific volume. Okay, we can think like that. Mm, From that, because N is not, we can't consider N here. Otherwise, everything is known. So only thing we can calculate using that volume is we can calculate the N. Yes, let me do it. Okay, this is for gas. And
Yes.
373 Kelvin, if you put, then N will be, pressure is 180,
180.
volume is, this is ATM. This is, yes. That's why something is missing. Otherwise, why they will give that data? T is, and now R is 1.987 liter ATM, right?
Yes.
And centimeter cube. So 1 centimeter cube is eventually, to convert 1 centimeter equals to 10 to the power minus 1 decimeter. Correct?
Yes.
And so here 1 decimeter cube is eventually 10 to the power 3 centimeter cube. So 1 liter is eventually 10 to the power minus 10 to the power 3 centimeter cube. So here 10 to the power minus 3 liter. Okay, so this is the N. So this is not 1. Okay, so it is, do you get the point? In
Yes.
general, we just consider N equals to 1, but here this additional data is given.
Will there a big difference of the answer?
Let's see. N is very small. We are getting, I don't know what,
2.2586 into 10 to the power minus
minus
3.
3. So you see, so obviously there will be a huge difference. So this n will be
Yes.
important. So then we can write it. So just we have to multiply it with n with this. So just do it the calculation. Take ln. Okay.
How can we apply this PV equal to nRT on the water, steam?
Because steam is a gas, we have to consider ideal gas. Otherwise, this formula is not valid even. Okay.
There is no other formula for this real.
Then you have to consider the van der Waals gas. For that, this is very complicated. This will be okay. When you are doing a problem, then you should not think like why you are applying the ideal gas formula. That is a theoretical perspective. But when you are doing problem, you have to focus on the problem. Just you have to get the answer. That time you never thought about any theoretical uh, issues. Okay,
Yes.
you should not. Okay, so now it will be, but this is a very bad answer. I think something is wrong. I'm failing. Don't know why.
What is the volume of 1 mole steam
That is given.
and 1 mole water is
That is not important because we have already considered that water has very less volume.
the N is too much small.
Hmm. And also, if you put with then delta T will be very small. Okay, let us check what happens. Otherwise, we have to follow the different path. So it is like this. Okay.
Yes.
Now T1, T2. So T1 is 373. T2 is T1 plus delta T that we need to find out. So we can write T1, T2 divided by del T is this. Okay.
Okay.
So now just write it T1 plus delta T to T1 divided by delta T. So this will be something like that. I think I'm not doing anything wrong. T1 is very negligible compared to this, so we can write it directly. So T1 square by delta T This is the delta T. Just this is, I don't know whether it is correct or not. But there is a different approach. You can also check that approach as well.
Another formula.
Not formula, but there is a different approach. Okay, I'll check that approach. Just you have to consider the basic Clapeyron equation. You don't need to convert the process Clapeyron from this equation. Just do it. Whatever it is. Let's check what happens. You just check once this calculation is correct or not. Is there any mistake or not? But the answer is not very odd. It's possible, but I don't know.
I am also getting the same.
Okay, then it's okay. Okay. So now you have to just use this formula. dt equals to this one. Then these things you can write directly Vg. Okay. So if you put it, so now dp is known. Actually, you have to consider here the pressure change is very small. So if that is the case, then dp you can calculate. How you can calculate the dp? Just do it. Okay, let me do it. Okay,
dp is given
dp is given, but that is in. Okay, let me write it. dp is 27.12 millimeter Hg, right? You have to convert it into ATM. So this ATM.
0.03568
So let me write 0
03568
ATM. Okay. Now the delta H is given in terms of calorie. So you have to convert the
yes
liter ATM into calorie. How you can do? R, because you
from
know
the R value
0.082 uh, liter
liter
ATM
atmosphere equal to 1.987 calorie.
calorie. So 10 calorie per liter. Yes, correct, correct. So 1 liter ATM equals to 1.9.
24.2317
Okay, I'll do it later. So dt is Vg is given, or just write it like this, centimeter cube. Delta H
537
is 537
calorie.
per gram.
Yes,
That gram we have missed, I think, right?
yes.
Mhm. That is also okay, as a per gram is there. That is not for. Oh, okay. That's why this happens. This is per gram. So here something is X, let's say that we have to multiply. How many gram is there? if there is n mole, if there is n mole for water, water is 8 for 18 gram is 1 mole, right?
Yes.
So n mole will be 18 n
18
gram.
gram.
Okay, so eventually that n factor will be cancelling out. So here will be just 18n and n will be goes away. Okay,
Yes.
so this correction should be there. So if we consider that correction, then what will be the changes? From here we have to change it. So this calculation will be now ln 7.20 into 10 to the power minus 6. Let's check it whether it is correct or not. Yes, I think this is correct. Hmm. Okay, so this should be the answer. So I'm not doing this. So if you follow this path, the answer will be the same. Okay,
This path is easy, better
this
than
path is
this.
easier.
Yes.
Okay, so you can follow this whatever you want. Okay,
Okay.
so now we can discuss the other questions as well. Okay. This question is okay. Hmm. So question number 5. There is lots of this. Okay, volume change is 0. There is no volume change. Okay,
Okay.
right.
It is parallel to x y axis.
Y axis.
Yes.
Let's see. You are correct, but You know dPdt equals to,
Del H by T del V.
and this is the slope,
Yes.
and slope is
Infinite.
means tan theta.
Tan theta. Tan
So
90.
if delta V is 0, then tan theta will be 1 by 0 or anything.
Yes.
So this is not infinite, this is undefined.
Sorry. Yes. It's undefined.
Okay. So theta will be
90 degree.
pi by 2. Okay, for first quadrant. So pi by 2 means just this, like this. Clear?
Where I will do this line, left side or right side or in the middle.
Anywhere does not matter. Does not matter.
What is the significance of this process? Where del V is 0.
This is kind of jump. This is called lambda type of phase transition. Different type of phase transitions are there. This is a special kind of phase transition. Okay. If you
Okay.
don't have a problem with this kind of curve, then why there is a problem with this kind of curve? Yes.
Yes. And the phase is not defined from which phase to which phase.
No, they have just said for any arbitrary phase. But you can think like it is solid to solid or solid to liquid, like probably it is solid to solid.
Yes.
Okay. So one more question from phase diagram. Then we can discuss that activity part. Four substances are given and their triple points are given. Okay. Sublime means
Solid to gas.
directly. So when the sublimation occurs, for any phase diagram question, just first draw the in any arbitrary phase diagram, let's say for water or anything, then you just read it. So this is our triple point, and sublimation means this. So sublimations occurs when you are increasing temperature, means you have to go in this direction, right? Oh,
Yes.
sorry. Increasing temperature means this direction.
This direction.
So that will occur only when the pressure is under the below the triple point. Then only it will occur.
Yes.
You see, if the pressure is greater than triple point, then anyway you will increase the temperature. It will be first solid, then liquid, then gas. Okay.
Yes.
So The standard condition means STP,
1 atm.
1 atm. Obviously, uh, standard 273 Kelvin. So here you see, only for this substance D, his triple point is 1.2 bar. Okay, here. So at
Yes.
standard pressure is under this triple point. So at standard pressure, if you increase the temperature, it will it directly sublimes. Is it clear?
Yes.
Or should I draw
Which thing?
the details with sublimation, melting? Is it
Yes, that
understandable or
it
not?
will be. Yes, it is understandable, but that will be more clear.
Okay, okay. Let me draw it. This is sublimes. This is
Melting.
melting. This is boiling. So when sublimation occurs, this is our now this is given. Standard pressure is 1 atm. This is our standard pressure. So sublimes occurs only when this any pressure is less than its pressure at critical point. Critical point means um, triple point. Sorry, whether it is A, B, C, you don't know. But for any substance, ith substance, if this is P is below PT, then it's possible. Now for A, PAT is given 0.2 atm, but P is 1 atm. Okay. For B, it is 0.4 atm. For C, it is 0.8 atm. So for all these three cases, P is greater than PT. So it will be first solid, then liquid, then gas. If you increase the temperature here, solid to liquid, then gas. Clear?
Yes.
So it is actually PT. But for D, 1.2 atm. Hence, pressure is essentially less than TPD. Then that means it will solid to gas sublimes. Okay.
Okay.
Now we can start the we can discuss the questions related to the activity coefficient. Just wait 1 minute. I just yes. Okay. This for this species we have to calculate the activity. So what is the difference between activity and concentration and how it is related to chemical potential?
For liquid, the activity is concentration.
No, never.
It is the ability to dissociate.
No. Activity means uh, act concentration. You can say like this. Let's say there is a government office, any office, post office, you can think like that. There are 100 people, they are working. Okay, so if they are working with their 100% strength, okay, fully active, if they are, then let's say one particular work will be completed, will take time 20 days, correct? But you see, you give the work to them and you see after 30 days they have completed the work. So their activity, what is their activity? Though their concentration is 100, the number of staff is 100, but their active number is not 100. What will be the active number? 66, correct?
Yes,
That,
66.66.
that is the activity, and 100 is the concentration. So this is the basic difference between activity and concentration. So why these things appears? Just you think, in office what happens? They interact with each other, they have interaction, they have mobile phones, they are talking to each other, these things are there.
Yes,
So if you make very separate them and you just remove the phones, then you see this activity will be increased,
yes,
correct? So here also in a solution, because we consider basically the solution, they're ideal, they're not interacting, but eventually they
yes,
will interact.
yes.
So if the solution are very less concentrated, very dilute solution, in that case they will not
They are
interact.
not interacting.
They will interact very little. In that case, you can consider the activity is very close to the concentration. Otherwise, activity and concentration are not the same thing. That will be purely dependent on the concentration. If the concentration is increasing, then the deviation from the activity will also be increased. Activity will be decreased. Okay. Is it clear?
Okay. Yes.
Okay. So you know this formula.
RTLN exercise
This will be AI instead of XI.
for this activity.
Activity. If it is uh, pure, totally dilute solution, then it's okay. And what this zero means? This is any temperature pressure. This is any temperature but 1 atm pressure.
Standard condition.
No. In standard condition, temperature is also fixed. This is not standard condition. Standard pressure.
Pure condition.
Pure is okay. Pure is okay. There is no mixture. That's why only I species is there. Okay. But this A is activity. So how you can write the A? This is called activity. Where does it go? Yes, sir. So this AI is written as this. M is the concentration. It can be molar, can be molal, can be anything. Okay. But here we are considering the molality in terms of molality.
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 Okay.
It can be anything. You can consider anything. But if you consider different thing, this gamma will be different, right? So this is called activity coefficient. This is activity coefficient. So if you write it, then it will be this. Okay, let's take a general example, then it will be very clear. Let us salt, ionizable salt, this is. So it will be, okay, it will be dissolved like this.
Yes.
Now, let's say the activity of the cation is A plus. It's dependent on species because I is there, and for anion it is A minus. Okay, is it clear?
Okay.
Okay, so if you write it, so total activity will be A plus to the power x, because x number of molecule ion are there, and this is a total activity. This is a definition. If you ask in question, then you have to remind the definition of total activity. This is the definition of total activity. Okay.
Okay.
Next, you can write, just understand it. It is not very difficult, but it is very confusing. So you can think, instead of X cation and Y anion, there are actually there are X plus Y number of ions. Correct?
Yes.
So you can think like a average activity. So that will be,
Average activity means?
let's say, mm, there are 10 ions. Just understand like the 10 cations with activity 5. Okay,
Okay.
10 cation with the activity 5. So it will be 5 to the power 10. And and 10 anions with activity of uh, again 10 to the power 5. Let's say here there are 10 cations with activity of 5. Here are 5 anions, but you can consider the other thing, 4, anything. Okay, is it clear? No, leave it, leave it. So this is total activity is clear.
Yes.
Oh, so what will be the total ions?
X plus Y.
X plus Y. So what will be the mean ionic activity? These total ions have the activity this. Then mean will be
This by X plus Y.
not by root over, because the number is in the power.
Yes. Root over.
So this, is it clear?
Yes.
And it is written as A plus minus because it is mean for plus and minus both. Okay.
Okay.
So it is written as like this. You can write from this, and these two both quantities are equals to total activity. Just see.
Yes.
Okay. So this is the formula. Or you can also write A plus minus equals to mm, A plus to the power 1 by Y, A minus to the power 1 by X. So this is not needed. Yeah, you can do it. Okay, so mean ionic activity is clear.
Yes.
Now Directly it will happen from this formula. Activity coefficient. You don't know the activity, you know the concentration. This is the concentration, this is the activity, this is the activity coefficient.
Yes.
So you can write it similarly. A minus will be gamma minus m minus, and A plus minus will be gamma plus minus m plus minus, like things. Analogically, this is true, this is there, but this is, we are assuming. Okay. If there is any confusion, you can ask.
Okay.
Okay. This we are assuming, instead of, let's say, X cation and Y anion, we are assuming there are X plus Y number of same ions. Then what will be the case? What will be the picture? What will be the
Yes.
effective activity? Like that. Okay. So what will be the total activity now? And total activity is written by A. Okay. So total activity will be now, you know the formula. Just instead of A plus, we can write it like this. Okay. This you can write. Just check.
Yes.
Yes. And also, you know,
Yes.
correct?
Yes.
If you compare, then similarly. So this is called mean ionic activity coefficient. Okay. This is our
Okay.
mean molarity, and this is mean ionic activity. Okay.
Okay.
Now, if you start from here, what will be the M plus and what will be the M minus? If the, you are giving this, right? This is in your hand.
Yes.
If the concentration of this sample, this species, is M in molality, this is a salt, M, then obviously what will be the concentration of uh, My plus?
Same as the M.
No,
That percentage of dissociation.
Xm, right?
Yes.
X time M. So clearly M plus will be now X times M, and M minus will be Y times M. Clear?
Yes.
So just put it. So it will be Xm to the power X, Ym to the power Y. So it will be, it's better to write like this. Okay. So this is our molality of salt. This is mean ionic molality. Okay,
Okay.
and it is written like as kappa times m, and this kappa is eventually x to the power x, y to the power y, root over x. This is okay. So this is the formulas. Just see it if there is any doubt. Now you can solve any type of question. Today we'll solve this only
How
four.
to find the activity coefficient?
That you have to you can find using the Debye-Hückel limiting law.
Okay, I know it.
Okay. So just check it whether
The
there
gamma
is
plus
any.
minus value.
Hmm.
Gamma plus minus value.
Yes. Gamma plus and gamma minus separately you will have, and from there you can calculate the gamma plus minus using this lesson.
Okay.
Okay. So this definition you should be very crystal clear. What is total activity? What is mean ionic activity? And what is the mean ionic activity coefficient? Okay. Now you can solve the questions. Whatever asked, question was we have to calculate the activities of this electrolyte. Activities means the total activity. A. Let's start with the mx. So we have done it for like these things, right? Here we have
Yes.
considered n, but here the anion is written like x. That is not important. Important is the coefficient. That small x is 1, small y is also 1.
Yes.
Okay. So if that is the case, and the concentration, this is m molar, let's say. Example, what is the example? NaCl, KCl, KCN, NaCN. These are all examples.
Yes.
So what will be our m plus minus now? X to the power x, y to the power y. So 1 to the power 1,
Under
1
root.
to the power 1 to the power 1 by 2 times m. So it will
Yes.
be m. Okay.
Yes.
So it is m. Now you know what is the our a. A was a plus minus to the power x plus y. So a plus minus square. Okay.
Yes.
And a plus minus was m plus minus into gamma plus minus.
Yes.
Okay. Put it. So okay. This you can calculate from the Debye limiting law. This is in your hand. Okay.
Okay.
So this is A. Now this is very common question asked in NetGate. Alternative year they ask basically. Next is MX2. What are the example? CaCl2, MgCl2. These are. So what is small x? X is 1, y is now 2.
Two.
So what will be our m plus minus now? This will be 1 to the power 1, 2 to the power 2, to the power 1 by 3
1 by
times
3.
m. So it will be
2 to the power 2 by 3.
4 to the power 1 by 3, right?
Yes, 4 to the power 1 by 3.
Times m. So a plus minus will be, sorry, a will be a plus minus to the power x plus y. X plus y is 3. So a plus minus cube. So put it clear.
M cube, 4m cube into r plus minus cube.
So this is the answer. Okay. Next is mx3. Example is LCl3. There are any other example, you know, but just solve it.
X is y, y is 3.
3.
1, 3 to the power 3 whole to the power 1 by 4. 27 to the power 1 by 4. M plus minus.
Okay.
Yes.
Next one. This.
X is 1 and y is 3. Sorry, x is 2 and y is 3. 2 to the
Okay.
power 2, 3 to the power 3 whole to the power 1 by 5 into m. 108 whole to the power 1 by 5.
Correct.
Yes. Yes.
Okay. So in general, what you can write, we have already derived up to this. The m plus minus is x to the power x 1 by xy times m. Right? Now we have to always calculating first a plus minus. A plus minus is m plus minus gamma plus minus. So it will be, you know, kappa times m. This is the kappa. Clear?
Yes.
So a is x plus y. So it is kappa to the power x plus y m gamma plus minus to the power x plus y. Therefore, now it is x to the power x, y to the power y. M x plus y. This is the direct formula. But this is very uh, confusing to remember. So it's better to do step by step, then it will be easy. Is it clear?
Yes.
Okay. Okay, so in next class we will discuss more about this activity coefficient or few examples and using the Debye limiting law as well, because this gamma plus minus will be obtained using the Debye limiting law. Okay, so from
Yes.
there you can calculate these things. So let me stop here. If you have any other doubt or regarding this class, you can ask. Today, whatever I have planned, I have done.
Where I will get these things?
This activity part.
Yes.
Activity part is also available in PG Kit. You can see there is available, or KL Kapoor. I don't know the exact volume, but in KL Kapoor also there is this activity part.
I need an inorganic book or not?
No, in physical book as well. You don't need inorganic book. This
Okay.
Iwabuke limiting law is also in physical. Okay.
In which chapter?
That I don't know. That you have to check in the context first. But it is there. I have studied from, I think from PC Rokkir I studied.
Okay.
From here, direct questions are asked basically.
And the previous part in which chapter or which area?
Previous part means this classes
The
Kaplan
third
question.
thing. Yes.
That is purely from Kaslan.
Okay. And one thing I want to know,
Hmm?
that is the fugacity coefficient.
Ah,
I am unable to
that
understand.
will I also discuss. Fugacity I will discuss.
This is in phase transition part in any
In
book.
next class I will discuss. Fugacity I will discuss, and
Okay.
this activity, rest of the activity part and the debivocal part, fugacity, debivocal activity. This part I will cover in the next class.
Okay.
Then I have to think what are the contents are coming, what the lectures are covering. Then I will prepare the other questions. But up to next class, I have already thought.
Okay.
Okay, so let me stop sharing first. Okay, next week, obviously, we'll meet on Sunday because in regular time from 4 p.m. to 6 p.m. Okay,
The
and
notes of the thermodynamics.
that I did not find out, but okay, I have to also check because tomorrow I am leaving. Tonight I will also check again. Uh, PDF I should have in my laptop. One note I have for the CSI note that I can share tonight. Okay,
Okay.
that I can share totally thermodynamics, only the
This
classical thermodynamics one.
this phase transition is also there.
Probably I'll share
I
it.
found I found the lecture was a little bit tough.
Lecture was tough. Okay,
The
okay.
fugacity part.
I will share the I will share the notes, and you go through the lectures. If you have any specific doubt in the lectures, you can ask me in the next class. Okay, or you can
Okay.
ask me in messages as well.
Okay. Thank you.
Okay. Okay. Thanks for joining. Let me stop here today. We'll meet again in the next week. Okay.
Okay.
Thank you.